This is about energy density in electrostatics. The energy stored in the system is the energy that required to construct the system. Okay, how much work that we push into the system. For example, if we have the system of 3 point charges, so I need to move the 3 charges for each location one by one. Okay, so first I need to move Q1 from infinity to point P1. So since there's no electric field because there's no charges in this area, I don't need to apply any force. I don't need to do any work. So I have 0 work here. And let's say I have Q1 here at point P1. And I have Q2 at infinity. Okay, so let's say this is P2 here. So I need to move Q2 to point P2. Now I have electric field produced by Q1. Then electric field produce the potential. So at point P2, there's a potential at point P2 produced by Q1. What does it mean? This means that if I have 1 coulomb at infinity, okay, if I have 1 coulomb at infinity, and I move to here, then I need to do this work. But I have Q2 coulomb, okay, then I need to do this work, okay, move Q2 to this point. So what is the equation of V21? V21 is the Q1 divided by 4 pi epsilon 0, and the distance between point 1 and point 2 is 1, 2. Okay, so this is a potential. And then I multiply with Q2. But now if I change the order of Q1 and Q2, so I put Q2 in here, divided by 4 pi epsilon 0 R21, okay, multiply with Q1, and I call this term is a potential, the work that moving Q2 to point 2 equal to V21 Q2 and also equal to V12 Q1. So this is work that we apply the energy to charge move from infinity to that point. So this is mean that we have Q1, then move Q2 to point P2. Okay, this one we have Q2, then move Q1 to point P1. This require the same work. So now we have 2 charges. We have Q1, we have Q2, okay, at point P1, point P2. Then we have another charge Q3, okay. So Q3 is at infinity, it's very far, but we want to move Q3 to point P3. We have electric field produced by Q1, and then is produce potential, and also we have electric field that produced by Q2. This also produce potential. So potential at point 3 produced by Q1 is equal to Q1 divided by 4 pi epsilon 0 R13. and potential at point 3 produced by Q2 equal to Q2 divided by 4 pi epsilon 0 R23. This one is the work that moved 1 coulomb from infinity to point 3 when we have Q1 here, and this is the work that moved 1 coulomb from infinity to point P3 when we have Q2 here. Okay, our chart is Q3, so we need to multiply Q3 here. Okay, so this is the work that required to move Q3 from infinity to point P3. So we need to add these two together, okay, to get the work. So I call work number 3 is equal to, actually we call V31 Q3 plus V32 Q3. From this previous equation, if we exchange this two and also this two, so we're going to have another equation, because then I will have V13 is the potential produced by Q3 at point P1. So we move Q1 there, so we need to multiply Q1, and we have this potential 2,3, mean that this is the potential produced by Q3, okay, at point 2. I need to multiply Q2 because I move Q2 to location P2. This one, move Q3 to point P3 when they are Q1 and Q2. Okay, this work for move Q1 to P1 when there is Q3. This is work for move Q2 to point P2 when there is Q3. This one is the same as this one. Yes. So we can use either one. Conclusion, we have 3 shots: Q1, Q2, Q3, point P1, P2, P3. The work that we need to make this system, okay, going to be the work that we move Q1 to this location. W1 is the work, okay, to move Q1 to point P1, and which is 0, and okay, plus W2. W2 is the work. Move Q2 to point P2 when we have Q1 there already. The last one, W3. Okay, so we move Q3 to this location that we already have this one and this one at the location. The equation become like this. This one. Okay, we have Q1 and then we move Q2 here. This one we have Q2, and we move Q1 here. Now this 2 is when we have Q1, Q2, and we move Q3 to here. So we have fault from Q1 and Q2. For this one we have Q3, and we move Q1, we move Q2 to here. We need to do the same work, okay? So that means this one and this one, they are equal. So if I add them together, just add them together, okay? Then I have this equation, this 3 term, I have this 3 term. So add together, I have 6 terms here. So you can see there's a potential at point 2. There's a potential at point 2. Okay. If I combine this term and this term together, okay. So I have potential at point P2, V21 and V23. V2 equal to V21 plus V23. Okay. So V1 is equal to V12 plus V13, and V3 is equal to V31 plus V32. So from here, I can call this potential at point M, okay, by sum up the potential that produced by other charge. So from here, then I can group this term and this term. And I can group this term and this term. I will have 2WE equal to Q1 V1 plus Q2 V2. Okay, so V1 is this term and this term. V2 is this term and this term. And then plus Q3 V3. V3 is this term and this term. We have 2 here. So I just divided by 2 both sides, and then I can get this equation. Okay, so this is the equation for work that we move 3 charges from infinity to its location, okay, at point P1, P2, and P3. And we can extend this equation to n number of charges. We can sum from n equal to 1 to n. Okay, so we can get the potential at each location, and then we already have potential at each point. Okay, then we just multiply charge to that potential, and we sum all of them together and divided by 2. So this is the work that we need to apply to move the charge from infinity to that location. The charge will absorb the energy, and this energy is going to store inside the system. So actually the work that we apply is equal to the energy that stored in the system. Okay, so we can call this stored energy. Okay, so this is the equation for point charges. There's one problem here though. If we have 1 point charge, okay, we say this is 1 coulomb. So how we construct 1 coulomb? 1 coulomb might be from 0.5 coulomb, and we move another 0.5 coulomb to this location. So we need to use infinite work because we have an infinite electric field at this location. So when we going to combine 2 charges together at one point, we require a lot of energy, infinite amount of work that we need to use, okay, to combine 2 point charge to be 1 point charge. So actually this is called cell energy, and this equation doesn't consider that energy. And actually in the real world, okay, we don't have a point charge. All the charge is distributed. It's never be at one point. So we're going to consider the equation for distributed charge.